The final CHUMP build is capable of performing basic arithmetic functions, conditional statements, and memory storage. CHUMP works by sending a clock pulse from two 555 timers to the program counter, accumulator, and address flip-flops. The clock signal is first fed into the program counter, which operates the clock signal to determine the line of code that should be read. To do this, the outputs of the program counter are connected to the program EEPROM, where the code written by the user is located. The outputs then select which 8-bit line of code to execute from the program EEPROM. The 8-bit code is written in custom Chumpinese language with an opcode in the high byte and a constant value in the low byte. To be read by the chips, Chumpinese needs to be converted into machine code, where each bit corresponds to a different component. To do this, a second EEPROM called the control EEPROM is used. A4 to A10 input pins of the control EEPROM are all grounded, while with the A3 to A0 input pins connected to IO7 to IO4 pins of the program EEPROM. The 8 output pins are used as control lines and are connected to the address accumulator and ALU. The write enable pin is wired high and the output enable pin is grounded. The constant is then fed into the A pins of the multiplexer, with the inverted RAM output is connected to the B inputs of the multiplexer. IO4 is used on the select pin as it outputs a 1 for a memory instruction and a 0 for a constant instruction. The multiplexer then uses the value to choose between outputting a constant or memory instruction, which is fed into the ALU, address register, and program counter. This allows the select pin of the multiplexer to output values from RAM when memory values are being read, and values from the program ROM when constant values are being read. Next, the value fed into the ALU is computed, outputting two 4-bit operand values that are fed into the accumulator. The output of the accumulator can be enabled or disabled using the IO1 pin on the control EEPROM. The output of the accumulator is then fed back into the ALU through the A inputs, as well as into the input pins A0 to A3 of RAM. RAM then stores the outputs of the accumulator into the address selected, and the output of RAM is fed back into the multiplexer. The accumulator wiring connects the D0 to D3 input pins to the F output pins of the ALU. The Q0 to Q3 input pins of the accumulator are connected to the D inputs of RAM to determine where the data is read or written to, as well as being wired to the A inputs of the ALU. The clock pulse is connected to the clock signal from our 555 timers. And the master reset switch is connected to the IO1 on the control EEPROM. The ALU is wired with the A inputs being fed to the accumulator, with the B inputs coming from the multiplexer. The S select pins, mode and carry, receive information from control codes on the control EEPROM, with the output pins connected to the accumulator. The CN+4, G, and P pins are all left floating. RAM is wired to the A inputs of the chip connected to the outputs of the address flip-flop, and D inputs are connected to the accumulator register. The CS pin is grounded, and the W pin is connected to the IO0 pin of the control EEPROM through an address flip-flop.